Hi, everyone. I'm Soroush. So I'm the last speaker for today, and I'm required by law to make a joke about how I'm the only thing standing in between you and drinking. But we made a special arrangement today, and so the drinks are actually going to start during this talk because you deserve nice things. So the organizers have kindly gotten you all Prosecco. They're going to be handing it out during the talk, which is going to be great. If you don't drink, I think there's also juice, which should be good. And then last thing is just trying to spill any, because we want to keep this place clean, because we got to come back here tomorrow. But yeah, so they're going to slowly come around and give everybody a little bit of something to drink. So yeah, woo! All right, so while they do that, I'm going to get started. So our story begins with this humble method. This is a method on NSString, and it's called contain string, and it tells you if one string is completely contained within another string. And it's a super useful function. I'm sure all of you have used it before, and it really belongs in every standard library. Pretty much everybody should have access to something like this. But what I find really weird is that this was only made available in macOS 10.10 and iOS 8.0, which is really weird. If it's something that is so useful, then why was it only added, 3 years ago? NSString has been around since the next step days, something like 20, 25 years. And only this decade did they get around to making a function for contain string. And cool. So the way that we used to do this, the way we did it before we had contain string, is we used this other function. It was called range of string. And instead of returning a Boolean, range of string returns to you a range. And you can use this range to do lots of interesting things, including checking for containment. So if you wanted to basically check for containment, here's how you would do it. So you have a haystack, and you're looking for a needle. So you'd write haystack, range of string, needle, dot location is not equal to ns not found. Now, I don't know about you, but I think this is super, super ugly. It's got this nonsense with locations and ranges. I don't care about ranges. I just want to know if the string was there or not. It's got a double negative, not equal to not found, which is extra confusing. And I wondered why it is that Apple doesn't give us these really simple things that we clearly deserve. And so and one of my friends tweeted at me. He's deleted this tweet, so it's going to be anonymous. But he wrote, the Cocoa team tried to avoid adding any API that might save a few lines of repeated code if it didn't add useful abstraction. Now, I think this attitude is fundamentally flawed, and I'm going to go into some of the reasons why I think that it's flawed. But basically, we're left in this ecosystem with all these holes. And in some cases, Apple will fill the holes for us, but in other cases, we have to fill the holes ourselves. So this is a category in Objective-C, and it works like an extension in Swift. And it lets you add a function to an existing class and add new functionality to it. So with this category, we can go ahead and wrap up all the nasty little details of range of string and put it inside of this category. So I don't think this is enough. And the reason that I don't think this is enough is because if you actually go and look at the data, nobody does this. So you open up GitHub, and you go to the search, and it searches all these open source projects. And you set it to search only Objective-C, and you set it to search for range of string. And you get 470,000 results of people using range of string. And if you scroll through these, you'll find almost every single one is just checking containment. And this is code that was written in the last 3 years. This is code that was written since we've had contain string. So this first one is checking range of string mayo.length is greater than 0. So it's checking, hey, does this string exist? They check a couple more things. The next example, range of string question mark .length is greater than 0. They're, again, checking containment. And you can just scroll through page after page, and all anybody is using this for is containment. And so if this is the primary purpose of range of string has tons of different capabilities. It can do regular expressions. It can do reverse search. It can do all kinds of weird stuff, but all anybody uses it for is contain string, which is weird. So they ended up adding this in iOS 8, which is nice. Finally, they did that. And of course, oh, that's not good. And it's available in Swift as well, which is also nice, also as of iOS 8. This is a problem in Foundation, and we'd also see that this is a problem in some of Apple's other libraries as well. So if we take a look at this is for the Swift standard library. This is some Swift 2 code, so shield your eyes. Some of these things are not quite accurate anymore. But this is an extension that I used a lot in Swift 2. And what it does is you give it a test and say, tell me when this thing passes this test. And it will give you the first element in a sequence that passes a test. I wrote this in almost every Swift 2 project I worked on, and I use it all the time. And you can see sort of at the bottom how it works. You have the numbers 1, 2, 3, and -1, 2, 3. And you find the first one where the int is less than 0, and of course it gives you -1. Now, this extension was so nice that Apple did eventually add it into the standard library itself. And they added a little bit of nice stuff, some throws and some rethrows. But I bring up these examples because I want to show that the world that we live in, the world that we have to write our programs in, is not static. We can change it, and it does change. And only from pressure from us do these holes get filled in and do these holes get patched. So we don't have to suffer through the different inconsistencies that the platform gives us. We can do things to change it to make it better. So what this talk is about a framework for how to decide when to add extensions to your project. I have 4 rules that I like, and we're going to go through those rules, and I'm going to give you a bunch of really cool examples of useful extensions that you might want to add to your project. And I want to get started. So this is the first of the 4 rules. Does it increase expressivity? All right. So let me give you an example. This is some really simple code. It's an array with the numbers 1, 2, 3, 4. And we want to generate pairs, right? So we want to get one array with the elements 1 and 2 together, and then the elements 2 and 3 together, and then the elements 3 and 4 together. This is really useful stuff. This algorithm is useful. Let's say you have a bunch of views, and you want to install a constraint between each pair of them. You can run your array of views through each pair and get the pairs, and then install one constraint between each pair. Another example is if we, one app I work on, we have a map, and the map has a path, and each path has a bunch of points. And we want to know how long this path is. So we get each pair of points, and we figure out the distance between those, and we add those up. So this is super useful little algorithm, and the way that Swift in the standard library wants you to write this is like this. Zip A and A dot drop first, which is terrible. When you look at this, you have no idea what it's doing. When you read it, it says, I'm zipping some array and an array with a drop first. So you have to read it very carefully. You say, OK, well, if I drop the first, then I'm left with 2, 3, 4, and then zip it with the original. So 1 and 2 go together, and then 2 and 3 go together. Oh, this is making pairs. And so you figure it out. And so the second time you see this in some code base, you'll say, oh, this is the code. I think this is the code that makes pairs. And so you go in and you say, wait, this is pairs. And then the third time you start to recognize it. And you build up a little alias in your head for what this code means. But this is crazy. We don't have to make aliases in our head because we deserve nice things. All right, we can make an alias in the code, and the code can be more expressive for us. So this is an extension on sequence called each pair. Woo! And there's an extension on sequence called each pair, and what it does, it fundamentally works with the same bit of code, zip self and self.drop first. And what it enables you to do is have a reader come in and look at your code and easily say, oh, this code generates pairs. Now I understand. It also gives you another special power, which is that you can use it in chains now. So if you had some array, and then you map, and then you filter, and then you do each pair, and then you map again, and then maybe you reduce, you can now express all of that in one big chain, where before you would have to use intermediate variables. So this is a super useful extension, and you can use it just by typing each pair, getting autocomplete, and then getting your pairs out of your system. So that's one really good example of something that increases expressivity. Another one, who knows what this evaluates to? Shout it out. 10, exactly, boom. This is easy, because everybody knows that when you read reduce and 0 and the plus, that means that it's summing up the numbers. But that's not what it says. It says that it's reducing 0 with the operator plus, which represents a function that adds 2 numbers together. This is Again, crazy. And you don't have to live like this. You deserve nice things. So here's an extension on sequence. And because of Swift's standard library's built-in protocol structures, you can actually extend every single numeric value all at once. And that includes every integer, decimal numbers, floating point numbers, CG float, all of it, just with this simple extension. And now you can just type sum, and it does exactly what it says. And so when your user is going to go read this, when the reader of your code is going to read this, they'll read the sum, and they'll know exactly what it does. We can even go a step further and do averages. Assuming your number is a binary floating point, because we have to do division, you can write code that will automatically do your averages for you. And again, this is something that can now be used at the end of a chain, instead of before you have to assign it to a variable, because there's two references to self. You need the reduce, and you need the count. In Objective-C, these are things that we would have done with key value coding. So we'd write value for key path, and then we would write @sum.self. But that worked with strings, and it parsed the strings, and it figured out what to do, and it was all stringly typed, and so if it failed at runtime. But this is all statically compiled, and this is all checked at compile time, and you know that it's going to work. This is way nicer than the way we used to do in Objective-C. And as we all know, you deserve nice things. Boom. So that's rule number one. Rule number one is, does it increase expressivity? Rule number two is really similar to rule number one, but it's slightly different, and it's, does it decrease noise? So we're going to look at some examples of that as well. So I think everybody's had this situation. You have some height, and you have some number of rows, and you want to multiply them together. So you obviously use the multiplication operator. You go to compile, and you get an error. And it basically tells you that, this is an int and a CG float. I don't know how to put these together. What is this? Give me something I can work with. And so, of course, everybody diligently goes in there, and they wrap the integer in a CG float, and then the system says, oh, I actually know how to multiply these numbers, and so it multiplies them for you. But this CG float in here is all noise. The reader of your code doesn't care at all about conversions to CG float. The CG float is 7 characters plus 2 more for the parentheses, and all they care about is the singular little character, the multiplication sign. That's all that's important to them. You don't have to live like this. You deserve nice things. Yes, I deserve nice things. So, you deserve nice things. You can override the multiplication operator and make it take 2 new parameters. One that's an int and a CG float, and one that's a CG float and an int. So it works both directions. And perform the conversion inside of here. And then you can go back and multiply your numbers exactly as you want to multiply your numbers. Now, some people have doubts about overriding operators, and I hear those doubts. Sometimes overriding operators can be very confusing. Sometimes the meanings aren't always the same between code bases. Sometimes the same operator does different things in different places. But I don't think that applies here. Everybody knows what the star means. Everybody expects that when you multiply a CG float and an int, that those things are going to produce another CG float. You're scaling a float. And because everybody expects it to work the same way, I think it's OK to add this as an extension in your project. Another example of decreasing noise, can anybody evaluate this in their heads? I'll give you a couple seconds. So not 1, 2, 3, negative 1, 2, 3 contains where not greater than 0. Does anybody, I'll give you a hint, it's true or false? True? False. This is impossible to read. These exclamation points are totally confusing. Half of us thought this was true, half of us thought this was false, which is basically we just guessed, I guess. And this actually represents a very simple algorithm that we use all the time. And if we add an extension for it, it makes it much more obvious what we're trying to do. The bottom row is a lot clearer. Are all of these values greater than 0? And the answer is obviously false. Everybody can immediately read that, and they know it's false. The extension is not terribly complicated. And now that I don't need to add first where, thanks. Now that I don't need to add first where because it's in standard library, this is now the first thing that I add to a new project. So along with all, there's another example. Try to parse this in your heads and see what you come up with. True, false? Any guesses? True? Some falses, some trues. It's false also. This, again, is another simple thing with a very simple name, but it's impossible to read if you only use this Swift standard library's built-in accommodations. So this is the function none, and if you read it below, it's very obvious. Does this array contain no elements that are greater than 0? And the answer, again, obviously false. And then the last one is this one, and there's actually no exclamation points here. It's just the same function as contains. And this is any. And usually, you don't need to add this because it's the same as a function that already exists, but I like to add it because it's a nice balance. You have any, all, and none. You don't have to add this one yourself, but I think it also reads kind of nicely. Are any of these values greater than 0? Yes. 1 is greater than 0. True. So that's rule number 2. Does it decrease noise? Now, rule number 3, you don't always have to follow, but it's nice if you can get it. And rule number 3 is there an optimization in the extension? So shield your eyes again, there's going to be more Objective-C. Oh no, there's not yet. OK, so another example here. I think this code is actually pretty easy to read. Filter all the elements that are greater than 0 and count them. 3. Pretty straightforward. But what's actually happening here is we're generating an intermediate array with this filter, and then calling count on it, getting that count, and then throwing the array away. Now, this is not the worst thing in the world. Most of your users never notice something like this, maybe if it's in a tight loop. But it's something that we can do better. We can make a function called countWhere, and instead of storing an intermediate array, it stores an intermediate integer. And it counts up that integer every time something passes the test, and then returns the value at the end. Now, in addition to being slightly more optimized, this function also reads nicer, I think. So you get 2 wins here, which is good. Now for the Objective-C, shield your eyes. Here we go. Let's say you're writing Objective-C and you had an array with 3 elements in it, A, B, and C, and you want to reverse that array. Now, standard Objective-C or Cocoa idioms would lead you to believe maybe this method is called reversed array. So let's go ahead and type that in and see what that does. And it gives us an error. No visible interface for NS array declares the selector reversed array. So you get upset. You go to Stack Overflow. How do I reverse an NS array? And of course, they tell you, array.reversedObjectEnumerator.allObjects. Obviously, why didn't you try that first? Which is way worse. And even worse than that is creating an object enumerator and then calling all objects on it copies everything into a brand new array. So if you had an array with 10,000 items in it, and you call this line of code, it'll allocate a brand new 10,000 item array, and it will copy every element. The last one of the original array goes to the first of the new, all the way back over, and copies everything into a new array. This can be very expensive. This is an O of n operation. Now, fun fact. If you pause the debugger, right, drop a breakpoint, pause the debugger, and go in once you've created this array, and you write into the debugger PO, array reversed array, lo and behold, you get something. That's really weird. You get an __NS array reversed. And you can imagine that this is basically an NS array subclass, and it contains an optimization. Instead of copying all the items from our array into the new array, what it does is it holds a reference to the old array. And then every time you request an index from the new array, it converts that and looks it up in the old array. So if you request the first element 0 of the new array, it'll get the count -1 element of the referenced array. And so this O of n operation has become an O of 1 operation, which I think is pretty nice. More nice things, Swift has this built in. When you call reversed on a random access collection, you get a reversed random access collection. And what that does is it stores a reference to the original random access collection, and it will get the right elements at O of 1 instead of looping through and copying all the elements into a new array or a new collection. So this is super nice. So that is rule number 3. Not always required, but nice if you can get it. Is there an optimization? Rule number 4 is, does it belong on every instance of this type? So let's take a look at an example. Imagine you had a dictionary in your app, and that dictionary stored a bunch of properties for a request. So it stores maybe a path, a method, a timeout, maybe some query parameters, a bunch of stuff. And you want to be able to build a request from this dictionary. Now, if you follow just the other 3 rules, I mean, this is a nice thing to put into an extension, right? You just put all this code in an extension on dictionary, and you could just call build request, and it'll build your request. But this is a flawed approach. There are a lot of dictionaries flying around your app at any given time, and most of them have nothing to do with requests. In fact, almost all of them have nothing to do with requests. So putting this code in that place is the wrong place to put it. One nicer way to do it is you might build a wrapper that wraps a dictionary and sort of acts as a factory to build these request objects from the dictionaries. So that might be one way to do it. Now, you might be saying, Soroush, this is crazy. Who would write code like this? You just made up a contrived example to sort of prove a point. And what I will say to that is that this is actual code that I've seen in an actual app that runs on the App Store. And it's not doing nothing, right? It's an extension on NS Dictionary. It's in the push notification category because it's for push notifications. And what it does is it digs out a key, APS, and it casts the value from that key to a dictionary. So it's not doing nothing, it's doing something. But most of the dictionaries that are in your app don't have anything to do with push notifications. In fact, push notifications are pretty rare in the grand scheme of everything that happens in your app. So this is not the right place to put this code. So the last rule of when you should extend a type and add something to it is, does it belong on every instance of that type? So those are the 4 rules. I'm going to go over some other stuff, just some random grab bag things here and there that I think are interesting that have to do with sort of this topic. So here's one. Uniquing elements is something that is really common. Lots of developers need to do it, and there's no way to do it in the standard library. And when you want to do it, people will tell you, oh yeah, just put the array into a set and then put it back into an array, and then it's madness. Don't go down this path. So you do the thing that Soroush told you to do, and you make an extension called unique elements, and that uniques all your elements. Except you get this error. Generic parameter source could not be inferred. Swift's error messages need a lot of work. What this is really saying is element does not conform to hashable, because to put something into a set, it has to be hashable. And our element doesn't conform to hashable, so we can add this extension sequence where element is hashable. This sucks. Now, if our element is hashable, it'll work, but if our element's not hashable, we just won't even get this in autocomplete. We won't even be able to see this, which isn't good. And it has one other problem, which is it doesn't preserve order. And preserving order is really important in a lot of cases. So the way I like to do this is a little bit more complicated, but gives us some nice benefits. So we make a function called unique elements by, and we pass it a block that tells you if these 2 elements are equal. And then we can kind of build a convenience accessor. If the element is already equatable, then we know we can use equal equal, which is really nice. To generate the body of this function, we need something to keep track of all of the elements that are unique. We loop through all the elements of self. We check if the current element is already in the array, and then if it's not, we add it. And we end up with something that uniques our elements, doesn't require hashable, doesn't even require equatable, and preserves order, which is really nice. Here's another good one. Sorting code, right? You use this function sorted by all the time, and you have to return a true or a false. But it's hard to remember what are you exactly returning. And if you option click on it, you can kind of see it says is less than, I think. And so you know you have to use the less than operator, which is great, but you have to look it up, which sucks. And there's one other small thing that's wrong here, which is there's a small bit of duplication. Almost never do you want to compare the same object but use 2 different properties. You almost always want to use the same property. So we've actually duplicated this code that accesses the property. So $0.number of residents and $1.number of residents is duplicated code. So if we factor that out, we end up with a really simple function, which uses what I call like a property accessor. And you can return any type you want, any type T that you want from that, as long as T is comparable. And so with that function, you can now write this code underneath, which is much shorter and easier to read and kind of rolls off the tongue. Houses sorted by number of residents, sorted on number of residents, which is nice. 2 things on this. One, I can't remember where I learned this. I think I learned this from Chris Eidoff, somewhere in the crowd. There he is. But we're not really sure where it came from. It's very useful either way. And the other thing is a little bit of homework. For extra credit, there is an optimization if you use this form of the function. If you use this form of the function, there's a way to write it where it's a little bit faster. And if you figure it out, come find me and tell me. I would love to hear it. But if you want a hint, think about how many times we call the property accessor and how many elements are in the array. So this is a super useful one. I almost never use sorted by just because sorted on almost always does exactly what you want it to do. Here's another cool thing. This is my friend Just Dave. He also lives in New York. He made a project called Public Extension, which he sadly doesn't post on much anymore. But it was a Twitter account where every day or every week he would post a new extension that was useful. And there's a GitHub repo, and it's sad that it's gone. I gotta get him to bring it back because it's such a cool little project. But if you're looking for cool examples of stuff like this is one interesting source to go to. And the GitHub repo has tests, it has playgrounds, it has all that stuff if you want to play with the different extensions. Another example, I mean, come on, like, I don't know what %02HHX means. I don't know what that means. I never want to have to type that. I don't care how to convert data into hex. It's not interesting to me. And every time I do push notifications, I have to go look this up to go find it. And it's like, this should just be in the system. Don't I deserve nice things? One other cool thing, one other good source of inspiration. I didn't come up with a lot of this stuff myself. First, where I didn't come up with. Unique, I didn't come up with. Any, all, none. I didn't come up with any of those. I stole them all from Ruby, which has a module called enumerable. A module in Ruby is kind of similar to a protocol in Swift, and enumerable corresponds to sequence in Swift. And if you go to the documentation for Ruby's enumerable, you can go find, they have maybe 100 different functions that you can call on any enumerable. And we have a lot of them in Swift baked into the standard library, but there's a lot that we don't. And I didn't present all of them here. There's still a few more. If you want something really interesting, go look up slice before. That's a really fun one. And there's tons of stuff in there that we can steal. It's super useful. And they're working with abstractions that we haven't even thought of yet because their standard library gives them to them. So if you want to pull something from Ruby's enumerable, one thing you might pull is chunk. So what this does is if you ever have like an API that needs to batch items, let's say you have 5,000 items and you need to send them up 200 at a time, you use something like chunk. Given the numbers 1 through 7, it'll give you one chunk with 1, 2, 3, one chunk with 4, 5, 6, and then whatever's left. And so it breaks things up into chunks of size 3. How would we write that? We could start with a stride. And that stride goes from the start index of the array, which is 0, and it goes to the end index of the array, which is the count -1, and then it steps by the size. And that gives us all of our starting positions for our slices. And then we can map over those steps. We can figure out what the end index is by taking our start, I, and then stepping forward by our size, and then basically generating a slice from that. This code is not my favorite version of this code. There's other ways to write it. This, I think, is the least confusing. It's already kind of confusing, but, you know. This is a super useful thing. When you need it, you want it to be there. You don't always need it, but when you need it, you want it to be there. I feel like I need dramatic music for this part. Maybe like an Inception gong or something. These problems are not isolated to Foundation. They're not isolated to the Swift Standard Library. They're all over. UIKit suffers from this as much as anybody. Right? So here's an example of something that I always forget how to do, calculating aspect ratios. Is it height over width, width over height? I don't know. If they would just give this to me, I would never have to look it up again. Fun fact, in an earlier version of this talk, I actually wrote height over width. And somebody called me out and was like, hey, this is wrong. And I didn't even know because, you know, I can't remember this stuff. So I want it to be built into the system so that I can easily access it. Here's another fun one. Let's say your user's panning around your app. They picked up some item and they're moving it around. And then some fresh data comes in from the server. So we have this update with fresh data function. So the user's moving stuff around. You need to cancel that gesture that they're working with. How do you do that? I don't know. There's no cancel method on UI gesture recognizer. So you go to Stack Overflow again. How do I cancel the UI gesture recognizer? And they tell you, well, obviously what you do is you set isEnable to false, and then you set isEnable to true, and that cancels it. Duh. And so you're like, well, the next developer that comes along is going to be like, what the hell is this? What do I do with this? So you add a comment. This cancels any in-progress gestures. You don't have to live like this. You deserve nice things. So this is a method on UI gesture recognizer called cancel. because UI gesture recognizer is the superclass of all the other gesture recognizers. They all get this for free. And you can just call cancel at any time and cancel a gesture recognizer. Here we go. And the code is much simpler, doesn't need a comment, and expresses itself. Last example, I've always wanted to know how to know when a view controller is on the screen, and there's no method for this, so I thought that Apple didn't want to tell me, it was a secret, I was supposed to use view did appear and view will disappear to figure it out. But it turns out it's actually really easy, but because they don't give you an affordance for it, you don't even know that it's possible. So if the window of the view is nil, then that means it's not on screen because it's not in the view hierarchy. This will actually load the view, so we can add another quick little optimization. And if the view is if the view is not loaded, it'll short circuit and just end. And if the view is loaded, then it will go on and figure out if it's on screen or not. So that's a nice little thing as well. I hope that you all remember that you deserve nice things. So that's my talk. Now I get to drink this.